Hi, you're going to love this today. Oh, you are so in for a treat with transformations. Something totally new. I don't think, well, when I say totally new, I think that you've probably talked about transformations before. I don't think you've ever dug into them this deep. So I'm going to take this pretty slow. This is kind of an overview today, and then we're going to break it down and we're going to look at every transformation individually over the next couple of weeks. So to start with, here you have your transformations listed here on this sheet. Now I've got a bigger one on the screen, and also in your slideshow there's a link to the same one that you see on the screen right now that you can print off. You are going to want to keep this handy for the next few weeks. This is going to be your lifesaver. Otherwise you're going to have to memorize this, and I know that you don't want to memorize this much information. So let's take a look at what we're talking about here. To start with, we have reflections. And reflection is just like you think of when you see your reflection in the mirror, it's you, only in reverse. Like if you touch your right eye for real, in the mirror, it looks like you're touching your left eye. A reflection is the same thing in reverse. So if something is reflected, you're going to see the same image. It's just going to be the reverse image. So if you look here, it says the flip. Reflections are a flip that's flipped over something. The flip is performed over the line of reflection. So there's a line that you reflect across that determines exactly where the change takes place. And then it says reflections are isometric but do not preserve orientation. They don't preserve orientation. What that means is, once again, if you're touching your right eye, your reflection looks like you're touching your left eye. So it's not exactly the same, but because it's isometric, that means it doesn't change size or shape. So a reflection would be a rigid motion. Now, if you've done your vocabulary already, you know what a rigid motion is. A rigid motion is one that does not change the size or shape. So even though the orientation changes, the way that it looks, the size and shape stays exactly the same. Whether you're touching your right eye or touching your left eye, your size and shape does not change. So that's what that means. Okay, then you have a translation. And in a translation, you take the exact same thing and you move it. If you think of language translation, if I say hi in English or I say hola in Espanol, I'm saying the exact same thing. I'm just saying it in two different languages, so I've translated it from English to Spanish. So it's the same exact thing though. So same here. Even though you're translating it, which means you're sliding it or shifting it to a different space, it's still the exact same thing. So of course it's isometric, and it preserves orientation. Everything about it's the same. It's here, now it's here, but it hasn't changed. Okay, dilations. Dilations are the next transformation that's listed here. And a dilation is when you make something bigger or shrink it. Like if you have a picture of your boyfriend or your girlfriend and it's just pocket size, but you want them plastered above the head of your bed so that when you wake up in the morning you can say, well, hey darling, there's that big dilation. Or if you go to the eye doctor and they put some drops in your eyes dilate and they get really small. So the pupils in your eyes. So it can get smaller or it can get larger, but it's the same thing. If your boyfriend's little picture and your boyfriend's bigger picture are different, something's wrong. Somebody switched the picture on you when you took it to Walgreens to have it blown up, because it should be exactly the same, just bigger. So they preserve orientation, but they are not isometric. So dilation is the only non-rigid transformation that we have. Dilation is the only non-rigid transformation because it does change size or shape, gets bigger or smaller. Okay, and then rotation. A rotation is exactly what it sounds like. A rotation just turns. If I rotate this paper, have I changed the size or the shape of the paper? No. Have I changed, I just realized that my screen didn't have rotation on it, but I guess that's okay. Have I changed anything about the paper? No. I've just rotated it. And you rotate by degrees. Like you think a circle is 360 degrees. So if you rotated this all the way around, that's 360 degrees. Half of 360 is 180. So if I turn it like that, that's 180. If I turn it a quarter of the way, that would be 90 degrees. Now, what if I turn it a quarter of the way this way? Still 90 degrees, but now it's 90 degrees counterclockwise. And so if you look at the bottom of this sheet, and for some reason it's not letting me move the other sheet. Let me try it again so you can see it bigger. There it is. Okay, at the bottom of the sheet, you can see 90 degrees counterclockwise is the same as 270 degrees clockwise. 180 degrees counterclockwise is the same as 180 degrees clockwise, because if you go 180 degrees this way or you go 180 degrees this way, either way you end up with the same thing, don't you? All right, so all of that is broken down here for you. And again, this is isometric. It does not change the size or the shape. Just because it rotates it doesn't mean it changes it. You can slide something, doesn't mean it changes it. I can reflect this across my hand and I would have another one over here, but it would change orientation, but it's not going to change size or shape. The only thing that changes size is a dilation. So a dilation is our only non-rigid movement, okay? The only non-rigid movement. Now we can do some things that will change the shape of these other ones, but they're just by themselves, they're rigid. If I add different, if I do a reflection and a translation and a rotation, then I might be able to change the shape. But doing just one, they're all rigid. Okay? All right. So, if you look at this flow chart, for the rigid motions, I have, I need something smaller. I have a translation. It's where you just move it. Translation. I hope you can see that. I have reflection. And I have rotation. Those are the rigid motions: translation, reflection, rotation. They don't move. They don't change size or shape. I'm sorry. They move. They definitely move. They don't change size or shape. They move somewhere. This one just slides. This one flips. This one rotates. But none of them change the size. So for the non-rigid motion, that's where the size changes, and that is dilation. Dilation, once again, is our only non-rigid motion.